Hi, our poster is displaying some results from a series of BATA studies, which were reviewing the beta blocking efficacy of some sodium salts. Sodium salts are beta blockers, so this means that they act directly on TAS2R receptors, which are receptors found in the oral cavity, which are responsible for conveying bitter taste perception. So beta blockers could be very useful for taste masking, particularly liquid formulations, which can be notoriously tricky to improve the palatability of and are frequently given to children. To set the scene, the previous work before this was to review the literature of such beta blockers acting on these receptors and to compile the information known on them and create a scoring system to assess kind of in real terms how they could be useful as excipients in real medications. So looking at things like their safety profile, their efficacy, their shown efficacy, and also their usability profile. So 3 compounds came out on top. So we had our sodium gluconate, sodium acetate, and sodium AMP. So we ran these through the e-tongue to understand at what concentrations these could really start to be effective, and if in fact we could go lower than what was quoted in the literature. So moving on from this, here this work assessed these 3 sodium salts, but this time using the rat BATA model, which is the brief access taste aversion model, just to identify really if this is an appropriate tool for developing pediatric formulations containing these excipients. So can we use the BATA going forward with sodium salts? Our rats were exposed to a range of solutions containing quinine at 2 concentrations. So we had a high concentration, an IC90 concentration, and also a mid-range aversive concentration, the IC50. And of course, our sodium salts were presented at a range of concentrations alongside those quinines. In terms of results, there was no significant dose-response relationship for sodium acetate or sodium gluconate in terms of improving palatability, although there was actually an increased lick rate to the IC50 quinine with sodium gluconate. You can see on the graph it's trending upwards, but this was not a significant relationship. On the other hand, for sodium AMP, there was a significant improvement to IC50 quinine first off at the top 3 concentrations of the compound. So starting at 10 millimolar NAAMP, you saw an increased palatability response. So importantly, this is in line with published human data. A human panel has shown that 20 millimolar of the compound has this effect. So these 2 are comparable. NAAMP also improved the high concentration of quinine, so improved the palatability of the IC90. This time it took 100 millimolar of the compound to do this, but still we saw a significant improvement in the palatability for the rats in terms of their lick rate. So our results here suggest that the BATA could be used to assess liquid formulations containing sodium salts, in particular sodium AMP, and then in turn these could be used to develop better pediatric liquid formulations with improved palatability and ultimately improved patient compliance.